Okay, so today we are going to discuss on the EKS, that is a Elastic Kubernetes Service. Okay, so when I created this EKS last time, so it has a documentation, but now the documentation might have been changed. So let's do it together while following the documentation. Okay, so what is first Kubernetes and why do we use it? So far we have been doing work on the Docker, right? So we know how to install the Docker, we know how to run the containers, we know how to create the images, we know how to expose the service, and we know how to access those, we know on how to persistent the volumes, right? So you have a Docker machine and you are running your application, which is perfectly fine. So what if you want to run more and more applications? So again, you have to have the bigger VM. So you get the bigger VM. So now what's guarantee that the VM will always be up and running? Since it is a machine, virtual machine, so it may be corrupted, it may go down, it may have some resource issue, right? Performance issue. So if the VM goes down, your application is down. So as a failover instance, so you have to have another machine and you have to install the Docker, you have to follow the same process in both machines. But only one service will be up and running all the time, second will be dead, right? So you are unnecessarily wasting your resources over there. And also, if your container is stopped, who is responsible for building up? Who is responsible for bringing it up? So again, someone have to have a keep monitoring your services. Again, it's a pain. So that's why to avoid all those issues, so we need to have a one orchestrator service which will automatically take care of all these type of small issues. So that is the orchestrator. So we have a Docker Swarm which we have been using earlier, and there is a Marathon as well, Mesos Marathon stream. But now we have a Kubernetes. So out of these three, so everyone voted for the Kubernetes because it's the open source and it's a proven that Google entire Google infrastructure or services are running using this Kubernetes orchestrator. So they are running everything inside the containers. So someone said that Google is having 200 billion containers running for their entire infrastructure, for their entire services. 200 billion containers. So and everything is running using their Kubernetes and some in-house products. Okay, so that's why Kubernetes is famous. So this Kubernetes is actually supported by the Google people. Okay, so and so Kubernetes has a lot of flavors. So Kubernetes as an open source, you can also go ahead and install it, configure it, right? But again, Amazon and Azure and IBM and some Red Hat. So these people have their own versions of Kubernetes. So they take the product as an open source and they put their own concept, they develop their own concept using that, and they give a offer to customers. So if we talk about the AWS, so AWS has their own Kubernetes called Elastic Kubernetes Service. Okay, so they maintain the entire Kubernetes. So as an end user, we are responsible for only for the usage. So if we have a 10 nodes, then we just pay the money for the 10 nodes. So they maintain our entire Kubernetes. We don't need to maintain anything. Same as Azure and same as IBM as well. Same as Google as well. So sorry, if an application is entirely using Kubernetes and they don't have any other infrastructure, then I would highly recommend that you prefer the Google over here, because since it is owned by Google and they have a good Kubernetes support and they have a good Kubernetes features. Okay, so people generally go for Google only for the Kubernetes service. Okay, now we are going to discuss about the EKS. So before jumping on to that, so let me bring up some slides if I have. Yeah, I'll just go over about some architecture. So that is not required, but it's good to have knowledge. Configuration. This is Kubernetes. Yeah. So Kubernetes structure, you have a master and you have a nodes. So master is actually maintained by your cloud providers like Amazon, Azure, and IBM. So if we have our own on-prem Kubernetes, then we have to install the Rancher. So Rancher is another flavor where we can install it locally. So then we are responsible for master and node both. But if we talk about the cloud providers, we are only responsible for nodes, not for the masters. So it's a PaaS service. So master will be maintained by them. Okay. So we have a kube control. You can call kube cuttle. People say kube CTL. So this kube control is a command line CLI. Like we have a Git CLI, we have a AWS CLI. The similarly, so we have here kube CTL, kube control CTL, where we issue the commands. So once the kube control issue the commands, your master has some components: API server, scheduler, etcd, and controller manager. So these are the components are there in the master. So API server is responsible for receiving the APIs. Okay, and the etcd is responsible for storing your cluster information, like how many pods are running, where it is running, what is the node, what is the CPU, what is the memory. Everything will be stored in the etcd. It's like a database, you can say. And the scheduler is responsible for scheduling your pods. Controller manager will take a call where you wanted to spin up the agents, I mean pods. And then we have a nodes here. So node 1, node 2, if you have a node 10, you can add many as a node possible. Okay. So every node we should have Docker running, because everything will be using running Docker, right? So Docker. Then IP tables. So IP tables are responsible for maintaining your IP list and the inbound and outbound rules. Kubelet is responsible for monitoring your pods and inform if something is not good. Kube proxy is the one who actually manages the traffic between the nodes and between the pods. So same structure will be there in every node. So let's check some more details about here. So master nodes, worker node, API server. So like a watcher, it watches and shares state of the cluster through API servers, makes changes to components like deployments. So controller manager responsible for managing your resources. If something is not a desired state. So similarly in Ansible, so we have, right? So we wanted to have HTTPD installed and the service always running. So if the service is not running, so what does Ansible do? It will bring the service up. The similarly here control manager. I want to have my Nginx pod always running. So if it is dead, this guy will going to start it. Kubelet is responsible for monitoring your pod specifications. As I said, kube proxy knows details like pod. So which pod is running, where it is running, how it is sending, what are the IP tables details. This is controls your rules. etcd stores your cluster information like your database. Okay, so this you would see in a typical Kubernetes architecture. Okay, so now since master is owned by Amazon, we just need to spin up these now nodes. Okay, so let's follow the documentation and spin up our Kubernetes. Okay, so this is the documentation they have provided. Getting started with the first cluster, they have documentation here. Yeah, so they have commands as well, but I think again they change the documentation. So now they're asking you to do it through the either through CLI or the EKS CTL. So like we have a Cube CTL, right? So they have a EKS CTL, but let's follow this. Okay. So prerequisites. So we need to have AWS CLI, Cube CTL, and the required IAM permissions. So we need to have these three in our machine. To set this up, I'm going to take a machine that I can configure. So I can go ahead and configure all these in my local laptop. But since we are maintaining Windows and Mac, so I'm going to do everything in EC2 machine here so that we can have same thing when we're installing it. So why sign in again? So I'll launch the instance. So one more I forgot to inform. So before we start the cluster, so cluster actually expects that it is created from a admin account because it needs permissions to your IAM, it needs permission to your nodes, it needs permissions to monitoring everything. So that's why the admin has to create it. So since we are already in the root account, I am going to create one admin account and then use that account to do all our EKS cluster. It's a first thing mandatory. So I'll go here, IAM, and then create the user first. So users, add a user. I would say Cube EKS admin. Okay. So I'm going to give both access, programmatic and console access. Auto generate password. No, I do the custom password. So okay, I create the group as well. Admins, administrator access. So the EKS admin user created, and this is his secret key. So I'm going to copy this quickly. This is my secret key, and this is the access key. So I got my admin account created. So now what I'm going to do, I'm going to use this guy to log into my instance. So what is the instance? If I go here, this is the console login. I copy this one, paste this, ask me for this EKS admin. So I logged in here. So I would be using this account to create everything. So now I go to running instances. I have 3 here. So let me launch one instance. I picked this Amazon Linux because it has already AWS installed, so I don't need to worry much. And this is the T2 micro. Okay, review and launch. Launch, use my Mac. So machine is coming. So the first machine that I need is coming here. Okay. So before starting to do, you must install the configure the following tools enforce to create and manage a command line tool for working AWS services, including Amazon EKS. This guide requires that or later this. Okay. For example, see installing, updating, and installing AWS CLI. So we need to use the AWS CLI and configure it. That's fine. So let's see if the machine has up. So machine is up. So I'm running this as a AWS EKS EC2. So I have this machine perfectly fine. Now, first I need to check the AWS command. Do I have AWS here? Yes, this says 1.18. What is the requirement of here? So later 1.18 to 210. So ours is 1.18 141, which is less, right? So we need to upgrade our AWS. So how do we upgrade AWS? So pip install AWS CLI -- upgrade. Pip is not available. We need to upgrade. Let's check the yum. Sudo yum upgrade AWS CLI. Why it is not? Okay, it is not getting updated. So let's upgrade the following this. So we are using AWS 1. Version, not the 2. Version. So Linux. So we have so many options here, but we are using yum here. Let's check if there is a yum available. This is using pip version. This is pip version. We don't have the pip. First, we need to install the pip, and then we need to do that. Do we have Python here? Python 2 is there, but how about the Python 3? We don't have Python 3 even. Okay. So let's first install the pip. I'll do it through the root account. So that is easy. Curl is done. Python get pip. So pip is getting installed. Pip is there. So now let's install the pip. Install AWS CLI -- upgrade. Yeah. So now let's check the AWS version. AWS -- version. So now we have 1.18 to 11. So this is the upgraded AWS now. So if you wanted to know the commands, here are the commands. So what I did, I logged into the root. I downloaded the pip. I installed the pip, and then I used the pip command to upgrade the existing AWS CLI. Now the version is 2.11. Okay, that is fine. So we met one of the requirement, AWS CLI. Now what is the next thing? kubectl. So they also say we need to configure as well. So we need to configure AWS. So let's configure AWS. So AWS configure. So it's asking for the access key. So let's give the access key here. Secret access key. This is my secret access key. And then region, I would say US East 1. Output format is as it is. Good. So we configured our keys. Now kubectl command line, we need to install the kubectl as well. So let's go ahead and check the kubectl. Do we have the kubectl here? Maybe not. We don't have it. Let's install it. So installing kubectl here. So it's easy to install. So it says Nginx Beijing. This is the Mac OS, but ours is Linux, right? Ours is Linux. This is the thing. So this is a 1.8. So pick the latest one. I just copy this guy. I downloaded the kubectl. It is so slow. Yeah. So if I see, I have the kubectl here. So let's move this kubectl to /usr/bin. Before that, let's change the permissions. Chmod a+x, everyone can execute kubectl. Now move this, move kubectl to /usr/bin. So if I do kubectl dash version, it's no version. Yeah. So now we got the client installed the kubectl, right? So we are done with the basic requirements. So first thing is AWS CLI, kubectl. Now they talk about IAM permissions. The IAM security principle that you are using must have permission to work with EKS IAM roles and service linked roles created. Yeah. So they're talking about whichever account we are using. Like now we have configured it, that account must have all these privileges. Since we have taken admin account, it has by default all the privileges. So we can skip this part as well. Now first step, create your AKS cluster. So they say important to get started as simply as quickly as possible. The topic includes steps to create cluster nodes, default, providing blah, blah, requirements. Yeah, they talk about again same thing. So first to create your cluster. So they are using AWS commands here. So they are using CloudFormation template to create the cluster. So we can use this thing, or do we have a console mode here? No, they haven't given the console. Everything is AWS CLI they are given. But I would think it will be easy for you to, if you see in a UI. We recommend that you familiarize yourself with all settings and deploy a cluster and nodes with the settings meet requirements. So let's check this guy, what document they have here. This is about EKS CTL. Yes. Yeah, this is the through the console. Okay. So the console they say, open this, create cluster, configure cluster, blah 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 blah. We need to give the networking as well. Point access, public endpoint access, click next. Yeah, let's do one thing. So do not mix some documentation here and there. Let's follow one documentation. So we can use the CLI only to do all this. Okay. So now first we need to create the cluster. I'm copying this. Okay. And then I'm running the command. Paste this. It is going to create my cluster. So let's see. The stack name says my EKS VPC stack. Okay, that's fine. So this is done. This is created. Now create cluster IAM role and attach the required Amazon EKS IAM managed policy to it. Kubernetes cluster managed by Amazon EKS may cost to the service JSON. So they say that we need to copy this. Now we need to create the role. Okay. So now I am going to copy the JSON. And this is the role. This will just create the role. The role is created, which is good. Attach the required Amazon EKS managed IAM policy to the role. Okay, I'll just copy this guy and paste. This is done. Now clusters, make sure the region selected in the top right console EKS supported. Okay, so now I need to go to the clusters. So I'll open up the cluster here. No, probably I don't use the console mode. Already I have my own steps right here. Where is this guy? Where I logged in? Yeah, this one. So let me go to the clusters. It is not coming here.
I think we should create a cluster.
Okay, let's say that you want to deploy your cluster to. If you want to deploy pods for that node, yeah. Oh, I think we just created the VPCs and all. Okay, now we need to do the create cluster. Okay, EKS clusters, EKS clusters. So I'm creating my first cluster here. Cluster, the name. So what name you want to give? So I want to give SUView EKS. Okay, Kubernetes version is 1.18, and then it talks about the cluster service role. I think we already created this cluster service role. We need to select that one. Configure cluster. So already it's there. It's popped up. That is fine. So let's me do the side by side. Yeah. So now next what they say, specify networking. They say about secret encryption. These properties cannot be changed after the cluster is created. Yeah, so we're not using any KMS here. So I skip this as it is. Next, networking page. Now let's click here. Now networking page, we are using the default here, but we need to choose the VPC that we have created. So in the first step here, when we ran this AWS cloud formation, so this has created the VPC for us separately. So we're not using the default one here, which is good. Now let's go ahead and choose that network. This is the my EKS VPC stack. Okay, selected this subnets. So you can select all the subnets by default. They're all selected, right? And then security groups. Do we have any security group created for EKS? Yes, there is one. They did not say about the security group here, right? But let's pick this up. Now, public and private are private. So which endpoint you wanted to access. So if you create the public, then you can access your cluster outside of your network. So since we are doing everything in the public, so let's choose this one by default. Okay. Now network add-ins, this is called the Amazon VPC CNI. So again, Kubernetes has their own networking concepts. Like in Kubernetes, entire network is a software actually. So each and every service provider provide their own networking feature. So Amazon has CNI, and Azure has its own CNI, and kubectl itself has a kubedn and all. So here we are choosing this VPS CNI, which is good. Now let's click next. Now this is configure logging. So if you want to create the logging, you can also create. So once you enable this, so this will create everything into automatically to your S3 buckets, right? CloudWatch logs. So I'm not enabling anything. I'm just giving as it is. Now cluster configuration. So what is your cluster, your size, your tags, your details, everything is there. Now you can click on create. So this EKS will take some time. it takes some time to have the cluster created. Okay, so now we have created the cluster. Let's go for step 2. So now we are going to configure our machine that it can communicate to the cluster, right? So we have the cluster ready. So how you will talk to the cluster? So each and every Kubernetes provide you the credentials that is called kubeconfig. So we have to have that kubeconfig in order to talk to your cluster. So that kubeconfig will be used in the kubectl. So like if you want to export, I mean, if you want to push your Docker image to registry, so what do? We do Docker login. We do Docker login and then Docker push, right? That will push the image. Similarly, the kubectl, so we have to have a kubeconfig. So this talking about the kubeconfig only. Okay. So usually they say wait, because once the cluster is up, then only we can download the config and then follow it. Okay, so we have to wait for some time here. I'm going to pause the video for some time. Resume recording. So now finally our AKS is active. Now let's go ahead and do the remaining step. So configure your computer to communicate. So we wanted to have one machine to communicate to our kubectl. So if it is laptop, we can use a laptop, but we're not using laptop. Rather, we are using one dedicated VM for this. That is fine. So now I'm going to run this command. So they say create or update kubeconfig file. If necessary, replace your US East 2. So, but we are using actually US East 1. Ours is US East 1. Sorry. So ours is US East 1. Copy this as it is and paste it here. Now let's go ahead, and the cluster name is also we need to change. So what is my cluster name is SUV EKS, right? Error loading namespaces. Okay, what is the name of our cluster? SUV EKS. So SUV EKS US East 1. Now let me go ahead and update my cluster. Update config. Added new context. So my new context is added. Okay, now let's try it. kubectl get svc. So if you get this output, it means your Kubernetes cluster is up and running. Okay. Now let's talk about this. So they say create an IAM OpenID connected ODC provider for your cluster. So for one cluster. So select the configuration tab. Okay. So let's go to the configuration tab. There is a configuration tab. Yeah, configuration tab. Click on the details. Details. Open IAM console at. So I need to open this guy. Okay. Identity provider. So I need to open one more thing. So let me open this, the new tab. So I need to open up the IAM here. IAM service. I open another tab and open the IAM. So they told me to go to identity providers. Okay. Identity providers. Add provider. Add provider. They say use OpenID Connect. OpenID Connect. Okay. So if I go here, I have the OpenID here. and paste it here. Get thumbprints. So STS, okay, let's copy. Do not mess it up. So this is like the connectivity. Now add providers. So provider is added. Okay. Now create the nodes. So now we need to create the nodes. So let's check this thing. Hmm. Let's use this guy. So first we need to create the IAM profile. Copy the following. Sorry, create this first. So if you want to know why we are doing this, you can read all these instructions. So they will give you good details and they are self-explanatory. I'm just trying to create this as quickly as possible. So this is the stuff, and then let's create. So do we need to make any changes here? No. So I'll go ahead and run this command as it is. An error, no such entity when calling action. We found. Did we run this? Oh, we did not create this. We need to run this and then this. I ran the second command directly. So first you create the role and then you append that role. Yeah. Now go to the clusters compute tab. Okay. Go to clusters compute tab. There's a Fargate profile, Fargate profiles. This was not there when I was working on. I think I used the nodes before, not the Fargate profiles. I don't know what this Fargate, but let's try. Add Fargate profiles. HTTP EKS Fargate profile pod execution role. I don't have the role here.
It is
Yeah,
saying to go to a IAM
yeah. I just have to refresh this. So which we have the public in it. So public. They say select the public subnets. Okay, that's it. And then pod selector. So they say namespace default. Okay, that's it. So default create subnet, not a private subnet. They say public, but they're not private. Oh, unselect any select. Oh man, I was a bit fast. So I selected. So I need to unselect, only the private needs to be added. Okay, default name, then create. Yeah, Fargate profile is created. So we have chosen this, we did not choose this. So let's go ahead and run directly. Now view resources. In the left pane, clusters, and then in the list of clusters, select the name of the cluster that you created. Overview nodes. Okay, this is my cluster. Overview. We don't have any nodes. Is it taking time? Or do we need to complete this thing as well? Let's read what they said. Select one of the following node type. To learn more about each type, see Amazon EKS nodes. After your cluster is created, you can add other node types. So we chose this. Select this step if you want to run Linux applications on AWS Fargate. So we created this, and we did this thing as well. Namespace. They say one, right?
Lokesh, I have one question.
Yeah.
For Kubernetes, we are using Amazon this one, right? So what about the Google? The Kubernetes is same in Google Cloud also?
Yes, the concept are same, but the implementation is different. So in a
The
Google,
naming,
you may not, yeah, in a Google you may not follow these steps, because step to install Google maybe is different.
the naming only different, our process wording is anything different. The Kubernetes here and there is same, right?
Yes, they call it here Amazon cluster, but
Okay.
in Google they call Google container Google Kubernetes engine,
Okay.
GKE.
Okay.
Yeah. So I think we have to do this thing as well, node groups and all. Let's do it from the add node groups. So there is a node groups here, right? Add node groups, but here what they say in this step, forget. So this compute. After that, no steps. They say one of these, right? Clearly, select one of the following node types to learn more about each type. Either manage node Linux or forget Linux. Okay, so let's do it from the node group here. So compute add node group. Let me refresh once before doing that. Okay, let's go ahead and create this node groups. Let me just check here. Yeah, we don't have the nodes. Let's add the nodes and see. So add node group. Enter the node group. They say SUV EKS node group. IAM role. I don't have the IAM role. Yeah, so this Fargate is not working. So let's
Lokesh, you have to create IAM role, might be.
no, not required. We have everything here. Don't need. This is only for the pod they're talking about, but yeah, let's do this nodes and see first. Okay, let's follow this node. Create IAM role Amazon VPN CNI installed. Copy the following content to your file name. Okay, so I need to copy this. So they're asking me to replace with your account ID and replace. What is account ID? Oh, my account ID. Okay. Oh, I think it's in progress. So can we wait some time? So let's wait for some time. So this is getting created. So if it doesn't come in within a few minutes, then we'll go ahead and do this thing. Okay. Let's close this. So keep this in. It says active.
So, Lokesh,
Mhm.
is terraforms and auto scaling are both the same? No.
No, both are different. Completely different. Terraform is infrastructure automation, whereas auto scaling is just to scale your VMs, your resources up and down.
Okay.
So like the way whatever you use console to create, right? Like EC2 machines, databases, and then this EKS,
Mm-hmm.
RDS. So everything can be automated through the Terraform. So you don't need to log into UI and do it. So if you
Oh,
have a Terraform, then you can automate all those.
so it
So you
automated
have
spin up everything, right?
you have to write the code for that.
Oh.
That's everything is code, right? So what do you think? Let's wait, or shall we go ahead and this? Anyway, let's follow this guy as well. Okay. So now I have this. I need to replace this with my ID. This is my ID. I'm copying this. So I'll go ahead and edit this guy. and then ID replaces with the OpenID provider URL XXS success ID OpenID provided URL. Okay, let's go back to our cluster, go to the details. Do we see OpenID provided URL? This is the OpenID provided URL, and I'll copy this guy and then edit. Ours is east, right? Not the US west. Replace US west as well. So ours is actually not west, rather east. US east 1. Perfect. Yes. Or even we have this thing here. Then US East one is replaced, ID is replaced. So with your account replace with the value from your OpenID Connect provider URL. The value from the OpenID Connect provider URL. What? Wait a second. OIDC provider, OIDC. Yes, US East one, Amazon ID. Yeah, we don't need to copy entire. We just need to copy this thing because it's like a duplicated. In here. It's already there, OpenID. US East ID, COM ID this, COM ID this, and then we have a OADC, OADC provider, OADC, EKS, US East 1, Amazon.id, ID. Yeah, that's it. This is saved. Now let me go ahead and create this role. It's done. And then attach the policy. This is done. Now this thing. Associate the Kubernetes service account VPC CNA plugin replace include your account ID. Okay. I will edit this command. I need to replace this guy with my ID. So where is my ID? My ID is this. Cluster name is not this. My cluster name is SUV EKS. Add-on. Okay.
Here we are using IAM console number ID.
Yeah. So this is what they asking to replace with the thing. Okay, it's also in progress. So this is done. Now we need to do this thing. I'm copying this and then paste this guy here. So do we need to do any changes here? Create node IAM role required Amazon EKS kubelet daemon mentions the policies. Okay. So they're not asking to replace anything because I don't see anything that we need to replace specific to our cluster. So I'll just copy this as it is. Role is also created and then I need to attach this. Okay. There are two commands. So first is this. Did we make any changes here? Did we make any changes here? No. It's done. Done. Okay, now we have to go back here, go to the overview. Still we don't have any nodes here. No. Configuration, compute, click on the add new group. So SUV, EKS, node group. I refresh this guy. So I need to use this role. Okay, let's follow this. Yes. Set compute and launch template. Now Kubernetes labels. If you want to add the label, you can also add the label. Yeah, let's don't do anything. Okay, this is the important. So this we need to choose which type of Amazon Linux we need to use. For the moment, we can see only these three coming up here, right? Because these three AMIs are actually uh, created to support the Kubernetes. So the only the basic one we have here is this. Okay, so now be careful that whenever you are choosing this, they are going to charge immediately because these are all not coming as a free. Okay, so AMI type and then what they say, we're in add group, right? They just say everything is next. Okay, on demand. So this is the thing, T3 medium. So there is nothing that we can choose for the free tier. Okay, so this will give you 4 GB memory and max 3 NIs. So instance types we have selected. Disk size. So what is the disk that we need to attach? This is about the auto scaling. So currently we have two nodes maximum, desired 2. So if you want to bring, we can also scale it, but let's keep it default. Click on next. Now subnet. So here already subnets are got selected and then key pair. So let's choose the key pair. So if you want to use your own key pair, we need to use our own key pair or we can use this one. But let me check. Select an existing key pair to use SSH key pair and then choose next. If you don't have a key pair, you can create one with the following. Yeah, so already I have the key pair here. I'm going to choose this one. Allow remote access from all. Okay, now click next. Everything is created. Now create it. So group is created. So now view resources. So I have to go to the EKS cluster compute. So this is group is getting created. So let's wait for some time. So we can also watch it here. So it will be inside our EC2. If I go to EC2 here, I would be having some machines coming up. You see pending. So these are the two machines that are getting created for my Kubernetes. So if I execute the command here, kubectl get nodes, it's not available at kubectl get svc. Still have this kubectl get nodes dash and don't have the nodes yet. Let's wait for some time. Once the node is created, then we can see it here. Yeah, it's getting ready. You see, not ready. It just started 6 seconds. So I don't need to use a different namespace. So two machines are getting created. If you want to check 192, 116, 14, 244. So if I select this guy, that will be in the same series. So 192, 168, 14, 244. Right? So it is getting created. So let's wait for some more time. Once it says ready, then we can start using it. So this is ready. So now technically our Kubernetes cluster is up and running. So we have configured our Kubernetes and we have configured our nodes. So we have to do so many stuff here. So we had to create some roles, we had to attach some roles, we had to create the VPCs. So what technically we have done here is, rather than we using the default VPC, so first we created the VPC by using a template. The VPC got created and then we created a corresponding role. After that, we created the cluster and we choose the versions. So once our cluster is active, then we went ahead and created the forget profiles. I don't know what that means. And after that, we created the node pool. So node pool is the stuff that we control. These are all the two nodes. Once the nodes are created, so your nodes automatically get attached to your cluster, right? And then the cluster must have access to do some stuff. The cluster must have access to provide access to your resources, right? So all these is being controlled by creating some roles and assigning to those. So where we have created the roles, all these here, you see, attaching the roles and creating those. This is what we have done now to create this Kubernetes cluster. Okay, so in a company, the process may be different. So they may be having a Terraform modules that will spin up the Amazon cluster, or they may be using the CloudFormation templates, or who knows, they may be also following the same instructions that is given here, right? So I always highly recommend whenever you are trying to create a cluster or any resources, I would recommend that you verify the Amazon documentation first. And then you go with some other processes if you're aware of. Because I created the cluster like 3 to 4 times. For every time, the documentation is different because the Kubernetes and the Amazon, the keep gets updated and the documentation changes. So they add more and more new features and they also try to make the user work hassle-free in installing the cluster. So now we have the cluster. So technically, so we have done this. Master is done, node is done, node 1, node 2. So I can log into this node. So if I want to log into this node, already has spun up using the public IP, right? So let's see. This is the public IP. I'm copying this. So let me use a new window here. So I'm all into this box. So this must be having already Docker running. See, already they have these many pods running, I mean containers running. Why? Because it has to support it, right? Clear? So that's what the setup of your cluster. Okay, and remember that you have to create a new account and give that account admin access, and using that account only set up the cluster. The reason behind this, so while setting up the cluster, whatever credentials we have used, whichever account we have used, only that user will have access as an admin initially. Okay, so if you create directly as a root account, then you have to use the root credentials to log in it. Okay, now we got the cluster setup done. What are the next steps? So any doubts on this, guys? So again, I'm telling you, you may not set up this cluster in a company, but this is like a knowledge purpose. Okay, so any questions?
No.
No. Okay, so now next step is to delete. Like I told you, cluster is expensive a little bit, so delete this once you are done with your testing. So now what I'm going to do, so just to save some bugs and also for the convenient purpose, so you guys can also install the Minikube. Minikube is another flavor of Kubernetes that you can run in your laptop. Because if you want to practice your Kubernetes, then you have to have your cluster up and running. So if you keep your cluster up and running, then what happens? You end up paying so much of money. To avoid that, we use the one node cluster Minikube in our machine. So you can use Minikube Kubernetes. You can install it in your local laptop. So they have installations for Minikube. So they get started here. So if you have Windows, you follow these instructions to install your cluster. So they have a Wingate package manager and the chocolate, yeah, package manager. So once you are done, then you are good. So if you're a Mac, it's this thing. If you are Linux, use this. Okay, so already I have a Mac. I installed the Minikube. So after you once you install the Minikube, you just need to start it. So Minikube start. I forgot. It's a VM driver. Virtual box. Yeah. So Minikube is starting now. This also gives me Minikube. So this is taking some time. Let it come up. It says launching Kubernetes.
So if we install this, we should not install that.
No, I mean saying
AWS.
AWS is for the enterprise companies, right? So if you want to practice Kubernetes, so you have two options. So one option is you can install the Kubernetes the way we have just described, explained. Your Kubernetes is up and running. So you can access your Kubernetes from here. Okay, but this is expensive. So you may have to keep your cluster up and running because now you may find half an hour time. You practice. Again, someone calls you. You take 1 hour break and then you come back. You practice for 1 hour and then you take a break. So you have to have your cluster up and running, right? So this will charge. So if you don't want to incur the money for the practice, then you can go ahead and install the Minikube in your local laptop for the practice purpose. Only for the practice purpose, we can install the Minikube locally. If you don't have the Minikube up and running, then you have to have the cluster up and running and you need to practice here. We just did the Kubernetes setup. We haven't actually executed any pods, any Docker containers over there. We are going to do that tomorrow.
In minute. Okay.
Yes, okay. So for the practice purpose, I have a Minikube here. So let me bring the Minikube dashboard as well. This is the dashboard. So this is called the Kubernetes UI. So Kubernetes also has a UI. So where you can see what is the number of pods are running, what are the deployments are running, what are the claims, like what are the jobs, what are the pods are running, and deployments, daemon sets, cron jobs, replica sets, controller, stateful sets, and then you can see the namespaces as well, right? So you can see all these in a UI as well. Okay. Some people prefer UI, some people don't prefer UI. I technically don't prefer the UI because I always take care of the through the command lines. This UI also gives you some flexibility to see how it working. Okay. So tomorrow probably I will start working on the Kubernetes commands, like how do we create the pods, how do we create the services, how do we create the deployments and deployment stateful sets, and then how do we have the replication controllers, how do we do the blue-green deployments, how do we promote our new changes without bringing our application down, and all this we'll discuss next week, and then tomorrow you would have the Kubernetes completed. So again, telling you Kubernetes is very important. So you may have to pay more attention tomorrow and day after. I mean, tomorrow, next week classes, because we'll cover all the resources that we are going to use in the Kubernetes. Okay. Any doubts? Hello.
No.
Yeah. So I will be explaining the remaining concept using this Minikube Kubernetes, so that it becomes easy for me to interact, because again this AKS will cost, right? So I'll go ahead and delete this cluster. So from tomorrow onwards, I'll use this Minikube to explain the cluster and their components. Okay.
Yeah.
Cool. So let's meet tomorrow then.
So here only for clusters, we are using Minikube. That's it.
No, the see, Kubernetes has so many flavors. So we have Amazon Kubernetes, Azure Kubernetes, Rancher Kubernetes, Google Kubernetes, and also Minikube Kubernetes. So we have different flavors. So we set up Amazon Kubernetes cluster just now. This is how, if the companies are using Amazon, they use it. So if they want to, if they are using Azure, they use Azure Kubernetes. If they are using Google, they use Google Kubernetes. If the companies like banks or some security companies, they don't go for the cloud. So they go for on-prem installation. So on-prem means they have their own physical machines, or maybe they have their own virtual machines, and they configure using Rancher. So they have these many flavors, but all these are expensive. So they are tied to money. So we are actually not implementing for the production purpose. We are just practicing. For the practicing, you can pick any of these Kubernetes flavors, or there is a free version, free flavor of Kubernetes, that is a Minikube. So whatever features we are getting in the Kubernetes is available in all these flavors, but Minikube is free. So that can be installed in your local laptop. You don't need to spin up a big VM, big physical machine to do that. So we are going to practice it in Minikube. So we learn the Kubernetes concept without paying money. That's a win Minikube is. Okay.
Excuse me, Lokesh.
Yeah.
Yeah, do you want us to set up like EKS once to get the feel or what?
I would highly recommend that you set up once, because watching is different and doing yourself is different. Because we did together, I was able to make it successful. So when you actually try to implement, then you may do some mistake. Then again, you try to go back and fix it. So that will give you some knowledge, like, okay, so I need to go to this cluster. So I need to create the roles. These are the ARNs. So these are the IDs. So these are the policies that we need to attach. So this, you will come to know some new stuff.
Okay.
Yeah. I would highly recommend that you do practice. Yes. Okay, so once you set up the Amazon cluster, then install this Minikube also locally in your laptop. Two different flavors of Kubernetes you would be having knowledge with.
Do we have any specific timings, like only for 2 hours it is free to create a cluster, or?
No, there is no cluster is not free. Cluster is not in the free. Yeah, it's always money.
So if to work for once, at least we have to pay something. That's what,
Yes,
right?
if you want to practice in Amazon, then you have to spin up your cluster and pay money to them.
Okay.
Yeah, I mean, it's not money expensive, but we have taken the T3 micro, right? So probably they will charge you like some couple of dollars.
Okay.
But again, so if you create it and you don't use it, but I would say you are paying money unnecessarily. So when you have an alternate option where you can practice the Kubernetes concept for the free, then why don't you choose that? This is what my opinion. Okay.
So once we create, we should delete it just for
Yes.
practice.
If you are not using it, delete it. Not only Kubernetes, any resource in Amazon, if you're not using it, delete it. If you don't delete it, then you are ready to pay money. I mean, if you're rich, I don't mind. You can pay to Amazon.
If we stop also, they'll charge.
If you stop, they don't charge for the compute, but they charge for the underlying storage. And if you are using multiple key pairs, they charge. If you are using multiple elastic IP addresses, yes, they charge. So
Even single Elasticsearch, I mean, Elastic IP address, they'll charge.
They'll charge, yeah.
Everything has to
that's
be
why.
yeah.
So that's why I would recommend that if you're not practicing, delete it. So Amazon doesn't take much time to spin up the new machines. It is very quick. Like if you have a Jenkins, if you have a Ansible installed, configured, and you are working on it, yes, you can keep them in a stop mode. But the things that you can quickly, immediately spin it up and delete up, just go terminate it.
Oh, the thing is, if you stop also, if you are not working, they'll charge.
Yes.
For the machines, I don't think so. They charge it if you stop.
If you have 4 machines, okay,
Oh,
so
okay.
they'll give you only 30 GB of the
Yeah.
disk free. But if you have 4 machines, so you have 40 GB. So 30 GB is free, so 10 GB, they'll charge the money. So if you accidentally created elastic IPs, then they'll charge. If you create the key pairs for different key pairs, then they charge for 3 more key pairs. And also
For
they also
security
have a
groups
networking.
So
Security
only
groups,
one
I
key
think.
is.
I think there are some security groups are free, like 30 or some security groups are free that we can create.
So key pair is one is free or two are free?
Only one is free.
we can use one for everything.
Yeah,
That is
we can
okay.
use one for everything. We have to use only one for everything. We use
Yeah,
multiple key pairs only if you're trying to integrate between the machines. Like Ansible needs to talk to its agents. So then we create Ansible key pair and then we use that key to communicate between the Ansible. So like same as with the Jenkins and the agents.
So Lokesh, we are using a red hat. That means we are using a one key pair, right? If you go for the Ubuntu and other operating system, so we can use
You can
other
use
key
same,
pair. That
no,
means
you
same
can
one.
use same key pair. You can use same key pair. You don't need to create
So
multiple.
we should.
Yeah.
If you create it, that means the operating system is changed, right? They will charge even though.
No, they don't charge anything. So key pair is just like a key and the lock for your machine to log in. So you can use the
Yeah,
same key. There is no.
but I'm asking like we are using different operating system, right?
Yeah, it is not. The key pair is not dependent on the operating system. It's like concept of
Okay.
logging into a machine. So machine can be of any OS.
Mm-hmm. Okay.
Suppose we installed Jenkins and we are not using, just we stopped. So they'll
Yeah,
charge.
one VM, there is no problem. So one VM, one key pair, small storage, one elastic IP. I mean one no elastic IP. So one machine, one security group, one VPC, one internet gateway, and few subnets. That is fine. It's everything is free. But if you have multiple VMs in stop mode, lot of storage, lot of EFS, lot of EBSS, then they'll charge for the volumes, everything. Okay, so let's meet tomorrow and let's discuss on the further Kubernetes concepts like pod creations and the service creations and the accessing those. And then we will finish the Kubernetes. And after that, maybe week after, we will pick up the Terraform as well. Okay.
Okay. Thank you, Lokesh.
Yep. Thanks, guys. Cheers.
Thank
Bye.
you, Lokesh.